Alright, so we're going to be looking at finding indices using exponents. So we've done this before. It's essentially writing all of this in terms of index laws. So if you don't remember your index laws, they're always a summary right here for you. So please look through them, take a moment to write them down and try and memorize them. So express 3 to the power of 2n times 9 to the power of 1 minus n divided by 81n to the power of negative 1 as a power of 3. So what we need to do first is to convert each one to the power of 3. The first one's already in terms of the power of 3, so we can leave that. Now 9 is 3 squared, and you have 1 minus n. 81 is 3 to the power of 3 to the power of n minus 1. Alright, once we've done that, we then need to multiply everything with brackets. Now don't forget, when you multiply with brackets, this is essentially one single term, so you need to make sure that you multiply the whole thing in brackets using the distributive law. Then write it out as one single power, add all the ones together on the top, and then subtract all the ones on the bottom. So grouping all the n's together first, we have 3 to the power of negative 3n, then you have plus 2 plus 3, which gives you plus 5. Okay, b, simplify that whole expression. As of before, we multiply all the powers together, so we get 3 squared, a to the power of 4, b to the power of 5, times 2, a to the power of 2, b to the power of negative 4. Then multiply all the numbers together, so we have 3 squared times 2, which is 18. And then add all the powers together, so you have 4 plus 2, which is 6. Then b to the power of 1. Evaluate 8 to the power of 2/3 plus 4/9 to the power of negative a half. So whenever you have a fractional power, that means you're gonna take the root of it. This is a cube root because that's a 3, and then we square it. Now just keep in mind that you don't have to do it in this order. You can always square the number first, then take the root of it. I'm going to do it in this order because then we get smaller numbers and it's easier to work with. Same with this one. You have a negative, which means we flip the fraction over. Then we have 1/2, so it's a square root. Okay, first term, cube root of 8 is 2, which is why I said we'll do that one first. Then you have a square root of 9, which is a 3, square root of 4, which is a 2. So you have 4 plus 3 over 2, which then gives you 11 over 2. Alright, so if we have equations where it's in the form of a to the power of x equals to n, we firstly need to change all the powers so that they have the same base. Now this example here, you can see that you have a 5 here for the first one. 25 is 5 squared. And 125 is 5 cubed, but then this is in a fraction, so we need to put a negative 1. So same as before, multiply all your powers. Then now, you might notice they all have the same base of 5. So now we can put all the 5s together first, so then it's easier to work with. So then we can now equate the indices because the base is the same. So then we have 8 minus x giving us negative 3. So then you just solve for x. Okay. Sometimes these equations are also in a quadratic expression. So if you have a look, if you write it in terms of 3 to the power of x, the first one's a squared, the second one's an x, and then the third one is x to the power 0. So what that means is we can replace this 3 to the power of x with something else, let's say y, and then we can solve for this equation. So y squared minus 6y minus 27 equals 0. Okay, so if we do minus 9 and a plus 3, minus 9 times plus 3 gives us negative 27, so that's good. Minus 9 plus 3 gives us a negative 6, so that gives us a middle term. So our number should be minus 9 and plus 3. So then we have y equals, y equals to 9, or y equals to negative 3. Then substitute the y equals to 3x back in. So we have 3x equals to 9, or 3 to the power of x equals to negative 3. Now, this is actually not possible, because whatever power you pick, the power cannot be equal to a negative number. So that's actually eliminated one solution. So then we have 3 to the power of x equals to 9. Is the only solution. If you rewrite this in terms of powers of 3 for 9, 9 is 3 squared, so then x must be equal to 2. Scientific notation. So we can rewrite all of these numbers in terms of scientific notation, and we're going to actually round it off. Oh, well, we're not going to round it off. Anyway, what you would do for scientific notation is you want to write down the first, starting from the left anyway, the first non-zero number down, put the decimal place, then write out the rest of the numbers. Then you want to say how many times you've moved it. If it's not a number less than 1, then you would actually be leaving this as a positive power. So the first one you've moved it 1, 2, 3, 4, 5, 6 times. So you get times 10 to the power 6. The second one, the first non-zero number from the left is 9. So do the same thing. Then this time, see how there's a decimal? This is a number with decimals. We're going to then put a negative on. Whoa, don't know what happened there. You'll put a negative on, then move it. 1, 2, 3. Okay, B, express the following as basic numerals. So you simply just write out how many zeros you need. Now, this is starting from the first number though, so each of these spots afterwards also counts as a 0 spot. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoop. Thinking in my head a 9, I should be writing a 0. So then you can check there's, starting from the back, 3, 6, 9, essentially 0 spots to get to 10 to the power 9. If it's a negative one, you move it to the left, so count it left 5 times. So 1 spot to get to the 1, so then 2, 3, 4, 5. Put the decimal there.